So hopefully you were kind of catching on to this when you were doing the 10 marks assignment. I did just want to throw you into that because I wanted you to focus on what does the graph tell you. Because I really anticipate them throwing some graphs at you on the final exam and kind of asking you questions from the graph. But they may just ask you questions given the equation. However, you have your calculator on the exam. You can use that. But it's going to save you some time if you realize what these different coefficients correlate to and mean. So the way I have it labeled, I've got a sine of bx plus c, closing the parentheses, plus d. Now, this also applies for cosine. Okay, same things apply for sine and cosine. They have the same characteristics. These coefficients do the exact same thing. Based on what you just did in 10 marks, what does the coefficient A correspond to? Anybody know? The height, the amplitude, okay? The absolute value of A, there is the amplitude. Now, if A is negative, it just flips your graph over, okay? So for sine, instead of starting by increasing, if it's a negative A, it's going to start by decreasing. For cosine, instead of starting at the maximum, if A is negative, then it'll flip it over so it would start at its minimum. So the absolute value of A there represents the amplitude. 2 pi divided by that coefficient B is going to give us the period. Okay, 2 pi divided by that coefficient B is going to give us the period. 2 pi is the standard period. So when we divide it by that coefficient, it's going to give us the new period. And y equals d is what? Anybody know? It's the midline, okay? That coefficient there at the end, okay? Sine of x doesn't have a coefficient at the end. The midline is y equals 0. But if we add something to the entire function, okay, think about our transformations of functions. When we add something to the end, we are adding that to all of our y values. So it's going to shift it up, or if that was, of course, minus d, that would shift it down that many units. So y equals d is your midline. You can pick that out of the equation right off of that. Now, the c is the only one that we haven't talked about. C affects what we call a phase shift. So let's just recap for just a second. A, the amplitude changes the height. Okay, it's a vertical stretch or shrink. Just like any other transformation we've talked about, when we multiply our function by a number, it's either going to stretch it or it's going to shrink it depending on what that number is, bigger than 1 or less than 1. B is going to affect our x values, the period. So it's going to horizontally stretch or shrink. It's either going to make that period longer or it's going to make it shorter, just like our other transformations. When our x is multiplied by a number, that's the horizontal stretch or shrink, changing the period specifically in this case. Adding something to our x's or subtracting is what shifts it. It moves it left and right. That's what the phase shift is. Okay, it's going to move this entire function either to the left or it's going to move the entire function to the right. So here's how we figure it out. You have to start by factoring out b. Now, it's not always going to be even factoring. Okay, so what I mean by that is if it's 2x, if you've got 2x in your equation, your plus c may not be 4 or 6 or something that's divisible by 2. You may have to factor out something that doesn't evenly factor out of the other number. So we'll look at a couple of examples like that. And then you take the linear factor, what you're left with after the factoring, set it equal to 0, solve for x. That is our phase shift. That's how we figure that out. Okay? So let's actually look at a couple examples of doing that. And they actually come straight off this worksheet right here. So let me give you one of those. Okay, so really the only thing new that I'm introducing to you right here is this phase shift idea and what the coefficients themselves do. You've already seen it, but we're just normalizing these coefficients here. Can't believe I'm a salesperson. Okay, so let's look at that very first example right here. Okay, the very first example, number one from your worksheet. Let's go through and we're going to identify these four things: the amplitude, the period, the midline, and the phase shift. We are not going to worry about actually graphing it, because if they ask you to just graph this function, graph it on your calculator, make sure in your radians, and just compare the pictures, okay? That's the easiest thing to do if they ask you to actually graph the whole thing. But all right, so the amplitude is simply the coefficient in front. Now, it is always positive. So in this case, the 5 is already positive, but if it were negative, the amplitude is always positive. Amplitude is always positive because it's talking about a distance. Okay, amplitude is a distance. All right, the period. The period is 2 pi divided by that coefficient in front of the variable. In this case, the variable is theta instead of x, but it's still our variable. And then you simplify that. So 2 over 6 simplifies to 1 over 3. Our period here is pi over 3. So instead of completing one cycle in 2 pi units, we're now completing it in pi over 3 units. We have shrunk this horizontally. We have really squished it. And remember, those transformations on the x variable are the opposite of what we expect. We expect multiplying by 6 to make it bigger. It actually makes it smaller. Okay, it's always the opposite. All right, in the midline, I'm doing these in order of, well, not necessarily simplicity. These three are easier than the phase shift, okay? So our midline here is just y equals 4. It really is as easy as it's just that constant on the end, okay? Now, the phase shift takes a little bit more work, okay? So the phase shift, we need to factor out the 6 from what's inside the parentheses there, okay? So when we take out a 6, we take it out of the 6 theta, we're left with the theta. Remember, factoring out a GCF is like you divide, or we're dealing with fractions here, so how about we look at multiplying by 1/6? So if we multiply 3 pi over 4 by 1/6, that is 3 pi over 24. Check it, multiply it back out. 6 times theta, 6 theta. 6 times 3 pi over 24, 6 over 24 leaves you to 4 in the bottom. 3 pi over 4. Okay, so our phase shift, we take this part of it and we set it equal to 0 and we solve for the theta. Okay, so our phase shift here so our actual phase shift is negative 3 pi over 24. So it's going to take our graph of the sine function and it's going to shift it left 3 pi over 24 units. Okay. Which simplifies, yes, totally forgot to simplify that. Pi over 8, right? 3 over 24, 1 over 8. That would make a little bit more sense, right? Negative pi over 8. Okay, negative pi over 8 units. So to the left. And remember, transformations, opposite of what we expect. When it's inside the function with the theta, we were adding, but it's the opposite, so we actually move it to the left. Okay? Let's do another one. Let's look at number 5. Number 5 is a cosine function. Okay? The same principles still apply. There's not really a huge difference between sine and cosine as far as their equations go. Now, I wrote this one, well, I didn't write it, but I picked one that had the different order so that we still realize, even though it's not written in the exact same order, it's still the same pieces. The amplitude is not 4, okay? It's not the first number you come to, it's the coefficient with the trig function. So the amplitude here is 1/8, so this one's going to be a lot shorter than our traditional cosine function. The Midline, let's go ahead and do the midline. I know that's not in order, but it's the next easiest one. Okay, the midline on this one is the same as the previous one. It's still y equals 4. Okay, 4 is the constant on the end, even though it comes at the beginning. It's the number that's completely by itself there. Okay, and it is positive, so it's y equals 4. So we've taken the entire function and we've shifted it up 4 units. The period. 2 pi divided by that coefficient of b, which in this case is 7, and 2 over 7 does not simplify, so it's just 2 pi over 7. Again, much, much shorter period than our standard. Okay, and then our phase shift, we factor out the 7, so, or we multiply by 1 over 7. So this is going to give us 7 times theta minus pi over 28. So our phase shift is positive pi over 28. Okay, I just didn't set it equal to 0 because once you get it to that point, you just change the sign. Okay, you just change the sign. So pi over 28. So it's not much of a phase shift. Okay, it's not much of a phase shift, but it does move it to the right a few units. Now, I do want to, let's look and compare on our graphs here. Make sure I'm in radian mode. Let me graph just the cosine function, the traditional cosine function, and then graph this one. Okay, I am going to change my window because I want to focus on just my standard 0 to 2 pi. And I'm also going to change my y values. My typical range is -1 to 1, but I know that my midline is at 4. So I got to go up above that. So I'm going to go 0 to 10. Okay, or no. Let me go back and fix that. Let me go back to -2, so I can see my whole original cosine function. I'll make that 7. Okay. So here's the original 1 cycle, a complete period of cosine, and then here comes the transformation that we have of it. You can see it's a lot shorter. I mean, you can barely see the curve in it in some places. You notice that it's repeated a lot more times. It's not just one cycle. There are a bunch of cycles there in 2 pi. Specifically, it would be, let's see here, 7 of them. There'd be 7 cycles between 0 and 2 pi. The phase shift is very difficult to observe. That's why I made sure that I showed you how to do that part, because it's very difficult to actually see that part when you're comparing the graphs. The amplitude, the midline, the period, those are pretty obvious, but the phase shift's a lot easier, or a lot more difficult to pick up just looking at it. You really do have to know how that works algebraically. Okay, so just make sure that